we had certain formulas where we had Vn is I and Rn, and then we had power is IV. So if I is V divided by R, so power is also V squared divided by R. Power can also be, the V is I squared R. So these are all possible values for the power. Right. So these need to be specific. So it has to be the specific current, the specific voltage, specific resistance, specific current, specific resistance. Okay. So, I can find the power. Think of another way to solve this. You can say the equivalent resistance was 1. Because we said, go back to see what we set this. So R1 was 1, 2. So put in the values of R there, 1, 2, and 3. So the equivalent resistance was 1. Right. So you can say all of the voltages are the same. Right. So you can say IS times R equivalent is equal to any V. So 3 times 1 is equal to any voltage. So the power is equal to the power of the entire thing, or even the power of each individual, is equal to the voltage squared 3 squared divided by Rn. So can I do it this way? It's the question. Does it check out? Does it contradict the previous method? Okay, in the previous method we had IS is equal to IN is equal to, and I have the place where I derived all these formulas before. IS times R equivalent divided by RS. Okay, so you have 3 times 1 divided by 3 is 1. 3 squared divided by 3 is 3. So it's not consistent. So why can we not do it this way? Rn. Ugh. Okay. So let's see if this works. Let's make sure this works. Okay. So IS3, this is 1. So we're going to do it for R3. So this is 3 times 3, so this is 1. So power 3 should be equal to IN, which is 1, times VN, which is 3. So it should be 1 times 3, which is equal to 3. So we have 3 squared with the voltage divided by Rn. So if we use the other method, we say power 3 is equal to 3 squared divided by 3, which is equal to 3. So we say power 2 is equal to 3 squared divided by 2, which is equal to 9 halves. Power 1 is equal to 3 squared divided by 1, which is equal to 9. So what was the mistake that I did previously? So I'm going to go to see if I can find the mistake. So IN is IS times R equivalent. So I got I3 is 1. And I got power is So power was I squared. So I wrote the formula for power down incorrectly in the last video, unfortunately. So what I'll do is I'll cut out the part where I solved for power from the last video, and then I'll just have this video be the power video. So if you're watching the videos, you already know that I didn't solve for power last time. Okay. So here we're showing that the power solving here, it proves that this formula is accurate. So I used this formula to solve power, and then I used this formula to solve power as well. So that proves that this formula is accurate. Okay, so it proves that the methods that I used before are accurate. And for the purpose of this equation, this is going to be 0.